experiments to explore how complexity influences human behavior decision making. By studying why individuals struggles in complex environment, he aims to improve policies in institutions while advancing economic theory. So I would like to welcome Dr. Oprea with us. Thank you for accepting this invitation. It's going to be a pleasure to have your presentation here. And I would like to double check with you. This is going to be recording. Is this okay for you?
Yeah, I was told it wouldn't be just posted randomly on YouTube.
Perfect.
It would be for internal use. That's fine.
Okay. If anybody needs captions for hearing impairment, let us know. We can activate that too. If not, we will proceed. Thank you, Dr. Oprea. Pleasure. And
Okay, well, thanks a lot for having me. I'm very glad to be here. I'm an economist. This is an economics paper, but it's at the intersection of economics and psychology, cognitive science. There's even a little bit of computer science in the paper. So we'll see how this goes. I hope you will feel free to interrupt me at any time during the talk, especially if I start using terms of art that are not familiar outside of economics. I'll be happy to pause and explain what I mean by things. Okay, so I'm going to talk about some experiments that involve me asking subjects to value a set of boxes, to put a dollar amount on how much a set of boxes is worth to them. Okay, so here's an example. This is not a visual task. This is just for you. I don't show this to the subjects, but this example, there are 100 boxes. Most of them contain $25, but some of them contain $0. And I'm going to be asking subjects to tell me how much this group of boxes is worth. Now, this problem is one of the most studied problems in experimental and behavioral economics and in lots of areas of psychology in a very specific form. This is a version of this problem that we call a lottery. And a lottery is this problem where I describe this set of boxes and I say some of the boxes contain $25 and some contain $0, and I tell them how many, but I tell them we are going to, if you acquire the set of boxes, we are going to open one of the boxes at random and pay you the amount inside. So just imagine you have, there's 100 boxes, each of them contains some amount of money, one of them at random equally likely is going to be opened and you're going to get the amount inside. How much is that worth to you? And the reason behavioral economists are interested in this is a way of assessing people's preferences for risk, which is the type of risk that shows up in financial markets and in health care decisions and all over the world. There's an idea in economics that we might be able to access how people's taste for risk by looking at how they value problems like this. Okay, so that's the starting point. We've been the typical way we ask for this value is using this thing. This is called a multiple price list. Okay, the way to think about this is the subject on each row of this table is going to make a separate decision between set A, with one set of 100 boxes, and set B, that's another set of 100 boxes. Let's just look at the first line for a second. Set A, all 100 boxes contain $25, which means if you get this set of boxes, you get $25 for sure, because even if I open one of them at random, all of them contain $25, you're guaranteed $25. Whereas this set of boxes contain 75 of the boxes contain $25, 25 contain $0. And so there's some risk here that you won't earn the $25 and you'll walk away with nothing. By having subjects make a separate decision on each one of these rows and changing the amount of money in this certain set of boxes, we can get a measure of how much people think the set of boxes on the right, which is maintained identically on every row of the table, is actually worth to them by looking at where they cross over from preferring the sure amount to preferring the lottery. So in this example, the subject preferred $25 to this lottery, 24, 23, 22, 21, 20, 19, 18, And then when it got down to $17, they preferred the lottery to this $17 for sure. And that tells us that the subject's value for this set of boxes is somewhere between $17 and $18. Okay, this is a way we've been studying lottery preferences in both economics and parts of psychology for decades. Okay, and the value, there's a special term for the value, the monetary value people place on a set of lotteries, and that is a certainty equivalent. The certain amount of money the subject thinks is equally likely or equally valuable to the lottery. Okay, everybody with me? Any questions? Okay. Okay, so now we've been studying certainty equivalence in behavioral economics and surrounding fields for about 50 years. And most of what we know about certainty equivalence is summarized in what Tversky and Kahneman, in a really famous paper, call the fourfold pattern of risk. Fourfold pattern of risk is important because it is what Tversky and Kahneman call the most distinctive implication of prospect theory. And prospect theory is sort of the most popular and best studied theory of decision making under risk in behavioral economics. And this is, one of the contributions that Daniel Kahneman won the Nobel Prize for in 2002. Okay, what is the fourfold pattern of risk? It's a set of regularities in the certainty equivalent. Okay, so I'm going to go over this a little slowly just to make sure it's clear. The certainty effect in gains is a tendency for people to look as if they're risk averse, meaning they don't like risk in a systematic way, for high probability gains. So when there's a really high probability of you earning a certain some amount of money, people's certainty equivalent, the value they place on the lottery, is less than the lottery's statistical expected value, which means that the on average, the expected value, the average amount you should expect that lottery to pay out, that people actually value it at less than what you should expect the value to pay on average. Okay, and that's means that the subject is acting risk averse. The certainty effect in loss says that people flip. People become instead risk seeking. Their certainty equivalent is greater than the expected value of the lottery for high probability losses. So when I move from gains to losses, your attitude towards risk flips. The possibility effect in gains says instead of being risk averse for high probability gains, people are risk seeking for low probability gains. So if it's really unlikely you're going to earn a positive amount, people look like they like risk. And it flips again. People are risk averse for low probability losses. Their certainty equivalent is less than expected value. So the fourfold pattern of risk is a series of apparent flips in people's attitudes towards risk as you move from high probability gambles to low probability gambles, or from gambles over gains, additions to your earnings, versus losses. And one of the reasons this is so important in prospect theory, and then the way behavioral economists think about risk, is it's one of the key pieces of evidence for something called probability weighting, which is a tendency for people to value low probability prospects as if they're more likely than they are, and high probability prospects as if they're less likely than they are. Okay, is this close enough to clear to continue?
Can I ask you something?
Absolutely.
So when you are trying to quantify or denominate certain effect is an attitude.
Yeah, it's often interpreted as a taste for risk, how your like or dislike for risk, like your taste for an apple or an orange, your taste for lotteries. This is how it's often interpreted. Does that answer the question?
Yeah. So what's the difference between an attitude and and what you said, a taste?
I think attitude and taste are pretty closely, I mean, at least the way behavioral economists use the words, are pretty closely related to one another. What I'm going to try to do in this paper is I'm going to try to contrast an argument that this is driven by tastes or attitudes versus an alternative, which is that it's driven by cognitive limitations.
Is this something that has to do with experience or applies also to novelty?
So that's a complicated question. There's lots of evidence that this stuff changes when people learn probabilities through experience rather than through description. I have some work on this. There's a famous, relatively recent finding for this literature, only 25 years old, which is called the description experience gap, which says that a lot of these things change in systematic ways if you gradually learn the properties of a lottery through experience versus explicit description of the properties of lotteries.
Okay, thank you.
You're welcome.
So glad to see in our field we consider those as endogeneity. It's a little bit complicated. It's like egg and chicken, you know. Like we try to use some exogenous effect in order to distinguish, you know, who came first.
But a lot of the conclusions are driven by this kind of static case. So yeah, and that may be radically incomplete. Okay, so okay, what I'm interested in this paper is understanding why people value things in a way that's different from expected value in this distinctive way of the fourfold pattern. And the kind of basic idea of the paper is that we can answer questions like this by thinking about what makes a lottery different from a simple dollar payment. What's different about a 75% chance of earning $100 and a 0% chance versus I'm just going to give you $75. And the traditional answer in the literature is that the main difference between those two things is the obvious one, which is that the lottery is risky. The lottery contains risk, which means its ex post value is not known to the decision maker ex ante. You know, before valuing the lottery, they don't really know what it's going to end up paying. Afterwards, they will, and that risk is what we're measuring. This is what makes lotteries different from a simple dollar payment, which could be a reason why people don't value these things at their expected value. And because, you know, the point of studying these is to study risk, the deviations of the fourfold pattern are usually interpreted as expressions of people's behavioral risk preferences, their taste for risk. This is the traditional interpretation offered in prospect theory, for instance, though there's a lot of ambivalence in the literature about exactly how to interpret it. What I want to point out here is that lotteries have a second property that makes them different from simple dollar payments that has been relatively neglected, which is that lotteries are also complex. It's not just that there's uncertainty in a lottery, it's also that the lottery takes a payment amount and it disaggregates it across multiple possible payoff spaces. And in order to try to put a dollar value on the lottery, you have to compress those arguments into a single dollar amount. And that involves a lot of information processing. You know, and if that information processing is costly, that's roughly what I mean by complexity. If it's costly to process that information, you should expect people to be tempted to substitute to simpler ways of processing the information instead, ways of processing information that might cause them to make mistakes. There's a bunch of lines of discourse in the literature that proposes theories of how people's cognitive limitations, rather than their tastes and preferences for risk, might generate patterns like the fourfold pattern of risk. Okay, now, if we wanted to study this experimentally, what I tell my graduate students when I tell them if they want to design a behavioral experiment to examine a behavioral mechanism, I tell them the gold standard is to remove the mechanism, the availability of the mechanism, and see if you can get the anomaly to disappear. Okay, so this anomaly of people valuing lotteries at differently than their expected value, if it really is driven by complexity, it would be great if we could just remove complexity and see if we can get rid of the anomaly. If we could do that, we'd have a good reason to say, yeah, maybe this was driven by the complexity of lotteries rather than risk. The problem is, this is an argument I make in the paper, is that this is a very difficult thing to do. And even if you could do it, it's very hard to verify that you've actually taken a complex thing and made it not complex anymore. And one of the reasons for this, in the case of a lottery, is that lotteries, by their very nature, by the fact that they're uncertain, are complex in the sense I just described. They always involve having payoffs happening with one probability and another payoff happening with another probability. There's always some sort of information processing required to value them. And that makes it very difficult to study whether this alternative possibility, that what looked like people expressing their risk preferences, might in fact be people responding heuristically to the complexity of the problem. Okay, so this is where I get the wacky idea for the experiment I'm about to show you. Idea number 2 is, instead of removing complexity from a lottery to see if the anomaly goes away, you can do the opposite, and you can remove risk from a lottery and see if the anomaly remains. Okay, so if you were able to somehow make a lottery not risky anymore, and you were to continue to see behaviors like the fourfold pattern, we'd have a good reason to think that maybe the fourfold pattern is not an expression of people's preferences for risk, but is instead a heuristic response to the complexity of valuing lotteries. And the claim in the paper is that this is a close substitute for this, what I tell my grad students is the gold standard. Once you remove risk from a lottery, there's very little to influence people's behavior towards them other than complexity. And I'll defend that in the context of the specific experiment I run. Okay, does everybody understand what I'm going after? Is it a good time to tell me if not? Okay, and this is the kind of key idea of the paper. When I started the presentation, I said that a lottery is 100 boxes. Some of them contain dollar amounts, some of which contain some dollar amounts, some of which contain others. And in a lottery, you take the set of boxes and you tell the subject, I will open one of the boxes from the set randomly and pay you the amount inside. A deterministic mirror of a lottery is the exact same set of boxes described in exactly the same way. But instead of saying I'm going to open one box from the set at random, I say I'm going to open all the boxes from the set, sum up the numbers inside and scale it by 100. And if you do this, you're maintaining a lot of the information processing involved in thinking about a lottery. You see the same numbers on the screen. You have to do something kind of similar with them, but there's no risk left in the problem anymore. Deterministic mirror, because I'm going to open all the boxes and sum and scale them, there is no randomness here, which means that there's no room for this to measure people's preferences for risk. This is just a funny box opening exercise, and there's actually a right answer. Regardless of what your taste is for risk, you should really value this thing at exactly what it's worth, or you'll end up over or underpaying for it. So to go back to the normal way we elicit people's preferences, their certainty equivalents for risk, their preferences for risk, I describe the number of boxes in 2 sets. I give the dollar amounts. I watch where they switch over from preferring the sure amount to the lottery. And the mirror screen is exactly the same screen. It's just that I've told them a different payoff. Well, I told them, essentially I'm going to pay you the sum of all of these of all these 75 boxes containing 25 and 25 boxes containing 0, and I'm going to divide it by 100.
So, Ryan, sorry about the interruption. So as I understand,
please.
the weighting matrix is just a risk probability of risk distributions, right? For the participants or for whoever.
For the lottery case, the lottery case is just a very simple probability. Yeah, it's a very simple probability distribution. Right?
And then for the A, it's you assume the uniform distribution for all the payoffs, right? It's
Well, set A, all 100 boxes contain the same amount. So in both cases, I'm going to open one of the 100 boxes uniformly at random.
Yeah.
And but in the 100 box case, all of them contain the same amount. So there's no actual randomness there.
Oh,
in
I
terms
got
of
you.
your payoff.
I got you. Thank you.
You're welcome. Okay, now if you do this, if you look at how people value a mirror, what I call a mirror of a lottery, I've removed risk from the problem, which means if I continue to see lottery anomalies like the fourfold pattern of risk, this kind of key pattern in the literature, we have a very good reason to think that this is being driven by information processing frictions rather than people's attitudes towards risk or their tastes for risk. One way of thinking about this is that mirrors just show us what types of errors people who are totally risk neutral make just due to complexity. People who have no, who value lotteries at exactly their expected value. A mirror tells us what kinds of mistakes they might be expected to make just because the problem's complex. We can't call these certainty equivalents anymore. When I look at a person's value for a lottery, or for a mirror, because there's no uncertainty on either side, both of these, this object now has a deterministic value. It's 0.75 times $25. We can't call this a certainty equivalent. This isn't the certain dollar payment that's equivalent to a risky lottery. Instead, it's just the simply described payment amount that the subject thinks is equally valued to the mirror. And if you value a mirror at anything other than its true expected value, you're just making a mistake. You're just leaving money on the table. You're risking. You're putting yourself in a position where you're mechanically going to earn less money. And no set of preferences over risk can rationalize that kind of mistake. Because the experimental design is very simple, and I'll be able to kind of walk through some of it in a minute. Subjects make choices in 12 of these multiple price lists. And they're kind of classic multiple price lists of a sort that are used regularly in behavioral economics and psychology to study people's values for lotteries and to measure things like the underlying parameters of prospect theory. But we have subjects value these multiple price lists under two payoff rules: the lottery rule, the standard rule, where there is risk, and the mirror rule, where we've removed risk from the problem. Okay, so the first round of subjects experiments I'm going to talk about are from 200 subjects in an online sample. Okay, now the main list that I have people value is lists that vary the probability of earning $25 between 10%, 25%, 50%, 75%, 90%, giving rise to lists that I'm going to call G10, G25, G50, G75, and G90. G stands for gains, and the number is just the percentage chance of earning the positive amount. So this example here is what I call G75. There's a 0.75 chance that you earn the $25. If it were, for instance, G10, where there's a 0.1 chance of earning the $25, it would be 10 boxes that contain $25 and 90 contain 0. I'm going to complement that with a set of loss lists. In loss lists, I give the subject some initial money, and I vary the probability of losing $25 from that initial amount of money between 10% and 90%, giving rise to lists that I call L10, L25, L50, L75, and L90. Okay, so what I'm going to be doing here is exactly what I need to do to study the fourfold pattern. I'm going to vary the probabilities, so I have low probabilities and high probabilities to look for people's risk postures flipping. And I'm going to have both, sorry about that, I'm going to have both gains and losses in order to study the other dimension of the fourfold pattern.
Sorry, Ryan. Let me ask another question.
No, please.
I keep interrupting you, so I'm sorry.
No. Questions are good.
Yeah, so this L and G, I would call them risk percentiles. Are they mutually exclusive in terms of the participants? I mean, in terms of the boxes? Like, let's see, the G90 will be the L10.
So the G90 is just it'll just be like this. It'll just have a 90 boxes and 10 boxes here.
Uh-huh.
There's no scope for losses, so they'll make a decision on this list. Then I'll
Uh-huh.
give them another one, which is G25 and G50, all with gains. But then they'll
Uh-huh.
also be doing a set of lists that involve losses where they can actually lose money. And they're totally separate tasks.
Oh, there are two there are two settings. So this is more like a punishment, and the other is like awarding, right?
Yeah, exactly. There's a loss.
Okay.
The typical phrases used are this is in the gains domain.
Yeah.
You have a possibility, the risk is over you earning some money. And
Yeah.
this is in the loss domain. There's risk you're going to lose some.
Okay.
And what the fourfold pattern of risk says is that people have totally opposite looking risk postures in these two cases.
Yeah, completely different story. Okay, I got
Yeah.
you.
Uh-huh. So every subject is going to experience all 5 of these
Mhm.
and all 5 of these, and then they'll experience a couple of other lists that I'll tell you about later.
Okay, and okay, maybe you already how did you I'm just curious, how did you design it? Like when you had this 200 participants, what kind of question you ask? Like what
Well,
or
I show them something that looks like this, so they can click on the screen to choose to highlight whichever side they want. And it's all programmed up in JavaScript and deployed online on a job site called Prolific, an academic job site called Prolific.
Okay,
Is
and
that what you meant?
yeah. And also, are they choosing simultaneously, or there's a sequential order of choosing it? Let's see
Yeah,
if I'm
yeah,
the yeah. Mhm.
yeah, they're assigned these in a random order. So I take all of these, all 5 of these, and all 5 of these, and every subject the software randomly gives them one at a time.
Oh,
They
okay.
make their decision, and they move on, and then at the end, one of the for 20% of the subjects, one of the lists is picked at random, and one of the rows is picked at random from one of the lists to determine their payoff.
I got you.
And then I wire them the money, basically.
Oh, okay. Interesting. Well, keep going. Looking forward. Thank you.
Okay. Now this is a kind of graph I'm going to show a bunch of times. So let me be careful about it for a second. On the x-axis here, I'm going to show the probability of earning that non-zero amount, which is either 25 or negative 25. And on the y-axis, I'm going to show the difference on average between the certainty equivalent the subject sets. In other words, estimated from where they switch from preferring set A to set B, and the lottery's true expected value. And as I said earlier, if the certainty equivalent is greater than the expected value, the subject's overvaluing the lottery relative to its, what it's expected on average to pay. We say the subject is risk seeking. If it's less than the expected value, they're underpaying. They seem like they're willing to sacrifice some expected earnings in order to avoid risk. So they're called risk averse. So this is going to give me a chance to, what I'm going to do now is not surprising. I'm just going to replicate using my lottery treatment what the literature has already shown. Okay, and so this will give us a chance to talk about the 4 pieces of the fourfold pattern. Certainty effect and gain says that when a lottery pays a positive amount with a high probability of gains, people tend to look risk averse. And so if you look at our lists, G75 and G90, that's what happens. You get people are valuing these things at less than their expected value. They're showing off what looks like risk aversion. Possibility effect in gain says if we move from a high probability to a low probability, the risk posture flips. They go from looking like they're risk averse to looking like they're risk seeking, and that's what we get in lists G10 and G25. Again, this is all very standard. There's a replication of something that's been done many times in the literature. Certainty effect on losses says, well, at high probabilities of losses, instead of being risk averse like they are in gains, people should be risk seeking. That's what happens in the L75 and L90 treatment. And the possibility effect in losses is that low probability losses, people become risk averse. Okay, and this is the fourfold pattern. The fourfold pattern is a series of flips where I move from being risk averse to risk seeking as I move from low probabilities to high probabilities, and I move from risk seeking to risk averse as I move from losses to gains. And this is something that's not predicted by kind of the standard normative theories of risk preferences in the literature called expected utility theory. Okay, and so the key question, the main contribution of the paper, is to ask whether this happens in these deterministic mirrors. When I remove risk from these problems, do people still behave this way? And so I'm going to show this in red in G75 and G90. You get the certainty effect in gains. You get the certainty effect in losses in L75 and L90, possibility effect in gains and possibility effect in losses. So all of the fourfold pattern continues to show up in mirrors, which means when I remove, and it's, you know, it's quantitatively similar as well. It's about 97% as strong, the deviations from expected value in the direction of the fourfold pattern in mirrors as it is in lotteries. Okay, and so you know, the natural interpretation that the design was set up to make from this kind of data is to say that most of this is at least plausibly driven by complexity rather than risk or taste for risk. Okay, it's a good chance that this is heuristic. And again, the kind of way to say this is that this really distinctive pattern of behavior shows up even in settings where it's an outright mistake, and even in settings where there is no risk, which suggests the possibility that these are not expressions of risk preferences after all. This is a standard way of showing this same kind of data in the literature. On the x-axis, so I'm just showing the exact same data I just showed you. On the x-axis, I'm showing the probability of earning the non-zero amount. And on the y-axis, I'm showing the ratio of the certainty equivalent to the non-zero payment. And if people were risk neutral, we would expect them to be along this 45-degree line. They're not. They tend to act as if they value low probability lotteries as if they're more likely than they are, and high probability lotteries as if they're less likely than they are. And this happens in both gains and losses. This is very standard in the literature. In mirrors, you get the same results. Now, this pattern is usually called probability weighting. It's an idea that people's valuations of lotteries are influenced by probabilities in ways that are difficult to explain on the basis of classic theories of people's taste for risks. But the fact that this shows up in a setting where there are no probabilities, these mirrors don't contain any probabilities, they contain weights, suggests that you get what looks like probability weighting even in settings with no probabilities. Okay, now I'm just going to pause for a second. To talk about the theory that this is all related to. The fourfold pattern of risk is important because it's a piece of prospect theory, which is this sort of extremely, for the last 50 years, has been kind of the dominant theory of behavioral theory of risk taking. Probability weighting, I already showed you what this curve looks like. People tend to overvalue low probability or prospects and undervalue high probability ones. There's another component of prospect theory, which is that people tend to not think about their final wealth when they think about the value of gambles, but instead that they think about the changes to their wealth. And I'm not going to go into the details of how this theory works, but because it's not necessary to understand what I do, but one of the important parts, regularities captured in prospect theory, is something called loss aversion, which is that when people face lotteries that mix gains and losses, they tend to put more weight on losses than gains. People have a specific, especially strong distaste for losses rather than taste for gains. Or in other words, sometimes the way it's heuristically put is that people dislike losing more than they like gaining. And this is another anomaly, important anomaly in the lottery choice literature. A typical way of testing this is a kind of more complicated price list. I had all of my subjects go through lists like this as well. This is a typical way of measuring the degree of loss aversion among subjects. Set B now contains nothing. These are always empty boxes. Set A is 50 of the boxes always contain a loss of $15, and 50 of the boxes contain a gain amount that changes from row to row, the price list. So in in the first row, for instance, 50 boxes contain $50, 50 boxes contain negative $15. So there's a 50% chance you're going to earn $50, or a 50% chance that you're going to, and a 50% chance you're going to lose $15. And you're being asked here, would you prefer this gamble where you might lose money to just earning nothing for sure? And as we go down the list, we're changing what that positive amount is. And then we're again looking for a crossover point. If people's crossover point, if the positive amount in these boxes is greater than 15, in this example, we'd say the person looks as if they might be loss averse. They're looking as if they're putting more weight on the loss component of a lottery than a gain part of a lottery. And this is loss aversion is one of the kind of key regularities in behavioral economics, one of the kind of cornerstones of the behavioral theory of risk. We're going to have two different versions. LA10 is a version in which you lose $10 if the 50% of the time, and we're going to have the ones that are pictured here, LA15, where you might lose $15. Okay, and I won't go into too much about exactly how I do this, but we can basically put this this data on the same kind of graph I showed the earlier data, where negative numbers are evidence of loss aversion. And these are very standard levels of loss aversion in our two lottery cases. The key finding here is that people also look as if they're very loss averse in the mirrors. Okay, why does this matter? This is a typical way of presenting loss aversion data in the behavioral economics literature. This is a parameter called lambda. This is an estimate of the multiplier you would have to put on losses in order to express how much more weight they seem to put on it. So if you put a lambda of 1 on losses, you treat losses and gains exactly the same. But if you put more than a weight of more than 1 on losses, you look loss averse. It looks like you're taking the losses more seriously than the gains. And lambda in most estimates is somewhere between 1.5 and 2. So people are up to twice as much weight on losses as on gains. The key finding here is that the same thing is happening in mirrors. This is notable because in mirrors you can't actually lose money. There are negative dollar amounts for sure in the mirror, but the mirror is you're going to be paid this for sure, which means 50. So for instance, in this line here, if this were a lottery, there's a 50% chance you're going to lose 15. But remember, a mirror pays 0.5 times 36 plus 0.5 times negative 15. That's a positive number. And so what looked like loss aversion in the context of mirrors, at least, is just negative number aversion. When you see a negative number, you kind of panic and overweight it. That's one way of interpreting it. Okay, now just sort of stand back. This is kind of a very typical empirical portrait of the main pieces of prospect theory estimated from the types of tasks I just showed you. Lots of probability weighting, lots of loss aversion, and you can see that things look very similar when you remove risk from the task altogether. And a natural question, a question I've been asked in seminars with economists is maybe could this be a coincidence? Could this almost identical looking pattern that happens in risk really be due to risk preferences, but be due to something that generates mistakes in mirrors? One way of testing this is because I ran this experiment within subject, I can test whether there's a relationship between these deviations in the case of losses in mirrors within subject. So what I did is I had a, yeah,
You mean, I'm sorry, do you mean the same test with the same person?
Yeah, so every subject was either assigned 12 mirrors and then 12 lotteries, or they were assigned 12 lotteries and then 12 mirrors. I randomized the order. I don't tell them what's going to come next. And so I can look at whether these deviations that I'm sure are due to something that I would call complexity in mirrors, these are just outright mistakes, actually predict across subjects how severely they're going to express these apparent tastes for risk. The degree they're highly correlated, there's a good reason to think that this is actually just an extension of the same mistake we observe in mirrors to the risky setting of lotteries, which influences our interpretation of the
Right.
pattern. Yeah,
I have a quick question regarding the
sure.
background of the participants. So are they your students or are they randomly recruited? Do you have their backgrounds? Because I have an overconfidence on investment paper, and we really found it's associated with how much you have, the total asset, age, education, and and such, right? You name it.
Yeah.
So I just want to learn who are the participants in your in the activity, and maybe they are those are the factors are associated with how they recognize the risk, right?
Yeah, so there's two samples in the paper. The big one is from an academic job site called Prolific. Prolific is basically you can make choices about who gets invited, or you can just kind of invite randomly from the subject population, and it's a broad demographic group. I think this current number of subjects on Prolific is somewhere between 50,000 and 100,000 or something, at least in America. And so
Okay.
these are randomly recruited without any account for demographics. So I don't, in fact, it's anonymous. I don't know who these subjects are. I can ask them demographic questions. I have some basic demographic characteristics. This is too small of a sample study to do anything serious with those demographic characteristics. We do know a lot of things about demographics and apparent risk taking using tasks like these. So for instance, we know that people tend to look as if they have stronger risk preferences. That is, they deviate stronger from expected value when they have lower IQ, for instance, or lower cognitive capacity. We know there's mixed evidence that women in these types of tasks look more risk averse than men, though that's sharply contested, and it kind of depends on how you ask the question. So there's lots of interesting space to explore there. I just don't have a sample that's well designed for that.
Okay. Yeah, I agree. It's like 200, yes. Because
There's 600 in the study overall. I forgot to say it. So the other half of it is I also have around 125 subjects who are students at UC Santa Barbara. So
I
that's
see.
the second sample where I replicate the main results there.
Yeah. Do you have a similar result? Like, did you obtain the
Yeah. Yep, it's in the paper. I think I don't have a separate graph on this, but yeah, with the student sample, you get similar results.
Cool. Interesting. Thank you.
Thank you. Okay, so the way to test for this association between the two types of deviations between the risky and riskless setting, or at least the way I did it, was I form an index of how far you deviate away from expected value in the direction predicted by prospect theory. I do this for the mirrors and for the lotteries. And so a positive number means you look very prospect theoretic, lots of loss aversion, lots of apparent probability weighting. And I could just draw a dot for each subject, since on the y-axis, I have the same error for the lottery, and the x-axis I have it for the mirror. And the main result is they're very sharply correlated with one another. Depending on how I calculate this, it's a Pearson's correlation coefficient of between 0.5 and 2/3, which is a very strong correlation. Okay, so there's reason to think that that these two types of errors are related, since that error can't be driven by risk or risk preferences. In the mirror case, one natural interpretation is that there are also errors in the lottery case as well. Okay, we could just ask some natural questions about the interpretation of these things. One natural concern is this might be contagion between treatments. Since I have people making decisions in each treatment, could it be that people are learning how to value these things in the case of lottery and then expressing their risk preferences in the case of the mirrors? Well, you can create a synthetic between subjects comparison, where there's no scope for contagion, just by chopping off the second half of the study. Since I randomize whether you do the mirrors or lotteries first, I can just look at people who have not experienced the other. When you do that, you get, obviously I get higher error bars, but it's the exact same kind of pattern of results. So this doesn't look like it's driven by contagion between treatments. Is this just driven by my inattentive online audience? This is my sample using UCSB undergraduates. And I'm also quintupling the incentives and giving them a lot more training. And you get, the same kinds of patterns of results for loss aversion and for the fourfold pattern. Okay, another possibility, if you remember, I described these problems as involving 100 boxes. Maybe those numbers are too big and it's making the arithmetic in people's heads too difficult. So I ran a version. You can do this for some of the lotteries, not all of them, because not all of them divide neatly into 4. But I can have a version where I say 4 boxes. So for instance, a G75, instead of being 75 boxes contain $25, 25 contain 0, I can say 3 boxes contain $25 and 1 box contains 0, and those are the same underlying probabilities, but it's presumably simpler to think about. And this graph I have on the x-axis, the 100 box version. I'm going to plot the deviations from the expected value maximizing choice. On the y-axis, I have the 4 box version. Okay, and for each of these, the lotteries, I can look at and mirrors. Lotteries again are in blue and the mirrors are in red. I can look at how different these are. If they're on the 45-degree line, they're the same, and you can see they're basically roughly the same. So when I simplify the algebra a lot, it doesn't make a big difference to the results. Okay, so this doesn't seem to be just driven by math errors.
So
yeah,
45-degree line is still means the risk neutral, right?
yes, that's right.
Okay, thank you.
Wait a minute. No, sorry. Sorry. Being at the origin, so being on this line and this line, is risk neutral. The 45-degree line is the 100 box version and the 4 box version are the same.
Okay, I see.
Yeah, so this is the this is the G75 list in the 100 box version. And the 4 box version, you can see that they're basically the same kind of deviation from expected value in both cases, regardless of how many boxes. So that's the general result. Okay. I also did a version of this where I tried to make it the simplest lottery possible. So instead of I use the 4 box version, but instead of paying $25, I pay $20. When you do that, now the math is just dividing 20 by 2 or 4. It's about as easy as it gets, but again, the results in the $25 and $20 reward case are exactly the same. So this doesn't seem to be about tricky math. Another possible hypothesis is that this is being driven by the fact that I, like most of the literature, use these funny multiple price lists problems where I have people make decisions in a big table. So I ran a version using something called the BDM mechanism, the Becker-de Groot-Marshak mechanism. And the BDM mechanism is a mechanism where I just show people the lottery and I ask them to type in how much they think it's worth to them. And then we have a payoff rule that incentivizes them to tell me what they really think it's worth to them. So it's a very, very simple screen where they're just putting in numbers. This is what the results look like. So I'm changing the method of elicitation. When I change the method of elicitation, I continue to get the 4-fold pattern and loss aversion. Results continue to look the same in lotteries and mirrors. But you can see that the pattern looks a little different. If I put them side by side, you can see the possibility effect in gains and losses are smaller in the BDM mechanism. Certainty effects in gains and losses are a little bit bigger. This turns out to be something that's been known in the lottery choice literature for a long time, which is the way you ask questions about people's preferences for lotteries. Multiple price lists versus BDM, for instance, actually really changes their apparent taste for risk, which can be kind of read as another piece of evidence. This really isn't revealing people's taste for risks. It's revealing something about the heuristics people use when they're not sure what things are worth because the problem is difficult. This doesn't even seem to be about valuation. Doesn't even seem to be about the problem of putting a dollar value on a lottery. This is from a paper by my friend and co-author Ferdinand Badir, in which he just has people choose between two lotteries. So show two lotteries on the screen, or show a simple dollar amount and a lottery on a screen. You choose which one you'd like, and you just do this over and over again for a lot of different things. Very simple to look at. Don't have to worry about putting a dollar value on anything. And you get something that looks like probability weighting there. This is known in the literature in risk, that's in yellow. You get almost exactly the same results in mirrors. So this seems to be a pretty general phenomenon that you can get some of these distortions that look like probability weighting, fourfold pattern, loss aversion, reference dependence, even after you remove risk from a lottery. And this suggests that a lot of what we've been studying as risk attitudes might contain a lot of something else, something having to do with information processing constraints. Okay, so what's going on? Well, in the appendix to the paper, and I talk about it a little bit in the paper as well, these prospect theoretic anomalies, these deviations from expected value that I've been talking about this whole meeting, are correlated with decision noise. So I had subjects repeat some of the tasks. So I randomly picked tasks where they had to make the same decision twice at different points in the experiment. And a lot of people don't give the same answer twice. And this is kind of a measure of how noisy people's decisions are. It turns out the noisier decisions are, the more you deviate in these directions. Cognitive uncertainty. This is by a measure of kind of the difficulty you have with a problem. It was proposed by my co-authors Ben Henke and Thomas Graeber. Cognitive uncertainty, you just ask people, how likely is it, do you think, that you made a perfect choice, essentially? And you can use that to study how doubtful people are that they made an optimal decision. That turns out to be highly predictive of these anomalies. Hasty decision makers, people who look like they're suffering from the fourfold pattern or loss aversion, tend to be people who move pretty fast, make their decisions quickly. Errors in the cognitive reflection test is a kind of a cognitive test that's used a lot in behavioral economics, predicts this. And also I have some self-reported measures of how inattentive or imprecise people thought they were. These are also very predictive of these prospect theoretic anomalies in both the lotteries and the mirrors.
Okay. And did you ask this question after they make the decision? Okay.
Yeah. So the decision noise is not actually me asking a question. It's just a measure, and so is the hastiness. This is just how long did it take you to input your answer. But yeah, the other ones are done afterwards.
I see.
What this, you put all this together, it suggests people look prospect theoretic when they use casual, imprecise strategies to avoid the cost of careful calculation. That's my interpretation of this. So when you look at these lotteries, you could pull out a calculator and try to do a really careful job, or you could just kind of wing it and feel it out. And this leads to, noisy decisions that are influenced by bottom-up attention, and so a natural interpretation of this is that that these anomalies were always more about these kind of imperfect heuristics people use and the kind of distortions they tend to create than expressions of people's true preferences for risk. And there's a class of mathematical models and that comes out of sort of the Bayesian brain literature in neuroscience and psychology called noisy cognition models, in which, and this is where this intersects most with neuroscience, is probably the best explanation for this data, is if people are imprecisely coding information about the value of these lotteries, or about the probability of these lotteries, if they're for instance neuronally using a finite number of neurons to code these this uncertainty, and the brain responds by combining that noisy information with a prior belief about what the properties of these lotteries might be. You can get results like this. This can actually produce things that look like the fourfold pattern on a basis that has nothing to do with risk, but instead it has to do with the imperfect way people who are not pulling out their calculator and doing a really precise job value things like lotteries.
In terms of that story, did you limit the time of answer for each? No?
Nope, they had all the time they want.
Okay. I see. Interesting. Like,
but we know we can intensify a lot of these
Yeah.
things with cognitive load or with time constraints.
Yeah. Yes. Yes.
Okay, so there's 3 ways of interpreting the data I just showed you. If you remove risk from a lottery, you continue to get these classic patterns of anomalies from the risk literature, which says that risk is not necessary for this kind of prospect theoretic behavior. A second interpretation that's perfectly consistent with the first one is if I take a simple dollar payment and I unnecessarily describe it in a lottery-like way using boxes and monetary amounts, so it requires the same kind of information processing that might be required to value a lottery, you continue to get prospect theory behavior, which suggests that complexity is sufficient to produce prospect theoretic behavior. So risk isn't necessary, complexity is sufficient. Another way of thinking about this is that if I induce risk neutrality, if I make it impossible for you to make decisions that aren't risk neutral without making a mistake in the standard ways we go about trying to measure people's risk preferences, you get significant looking prospect theoretic behavior, which means that based on this data, we should expect people to look very prospect theoretic, even if their true taste for risk is totally risk neutral, because of the types of mistakes people seem to make. Okay, so the big conclusions that I draw from the paper are even the simplest seeming lotteries are complex, which just means their values aren't very transparent to them. Usually when we ask people questions about the risk preferences, like the ones I motivated the study around, we assume that people have kind of direct and easy access for their true taste for risk. I take this kind of evidence as evidence that might not be true, that it might be difficult for people to attach monetary values to their taste for risk. And so people end up responding to those costs and difficulties by using kind of rules of thumb and heuristics that are noisy and inattentive instead. And that this might be what's driving a lot of these anomalies. A second conclusion is that the anomalies of prospect theory are largely driven by disaggregation, and the complexity generates, not risk. So if you fully take seriously everything that I reported in the paper, this important foundational theory in behavioral economics might, to a great extent, be a descriptive theory of complexity, not a descriptive theory of risk. And I think this has 2 implications. One, it limits prospect theory in the sense that it means that we can't learn things about people's true attitudes towards risk or taste for risk just from watching their behavior in tasks like the ones we've used to try to measure this, which means that we can't do things like design policy around this in a way that tries to accommodate people's preferences for risk. On the other hand, it expands things like prospect theory because it suggests that the kinds of patterns that we've been studying for 50 years in the risk literature apply a lot more widely than we thought they did. They don't just apply to risk and uncertainty. They apply to settings that are complex but not at all uncertain. And this is something that shows up over this kind of complexity shows up a lot in economic and social decision making. So one question, that follows directly from what I've just said is the question: how much of behavioral economics is actually like this? How much of behavioral economics involves phenomena that look like they're expressions of people's tastes and preferences, but are in fact expressions of the kinds of heuristic errors people make? Here's another paper with Ben Anke and Thomas Graeber that's forthcoming at the Journal of the European Economic Association. That has to do not with risk preferences, but with time preferences. Very, very important in economics. Elicit people's willingness to pay. Ask people in a sensible way, how much would you be willing to pay now for $50 paid in 12 months? And the way what people are expected to do under sort of standard economic theory is there's as I move that 12 months further and further in the future, your per period, so for instance, your monthly discount rate, the rate at which you reduce your value for payments that are pushed out in the future, should be constant. This is called exponential discounting, which means on a graph like this, which shows the time delay for this question at 1 month, 2 months, 12 months, 24 months, 36 months, 48 months, it should be a straight line. It's not a straight line. This has been known since the early 80s at least. It's downward sloping. This is a pattern, a famous pattern in behavioral economics called hyperbolic discounting. People tend to have their apparent impatience fall as the date goes further into the future. We can ask a companion paper. This is a question that we ask in this paper. What if we ask people to give us their willingness to pay, not for $50 paid in 12 months, but $50 just shrunk 12 times by 4% each time, and then paid to you right now. So there's no time involved at all. You get the exact same pattern. You continue to get a hyperbolic discounting. Hyperbolic discounting is often interpreted as an expression of people's the special way that they have preferences over time-dated payments. But this is something we call an atemporal mirror rather than a deterministic mirror of an intertemporal choice problem, and we get the exact same results. So it suggests that this kind of pattern is also probably largely driven by complexity. This paper is a contribution to an area in behavioral economics, a kind of movement in behavioral economics that some people call cognitive economics. That's has strong connections to cognitive science and neuroscience. And what it's doing is what we're trying to do in this literature is we're trying to look for regularities that cross domains of decision making like risk and time and apply to lots and lots of things at once to create more parsimonious models built on things we know about people's cognitive capacities. An interesting observation based on the two things I just showed you, probability weighting, the foundation of the fourfold pattern of risk, and hyperbolic discounting, which I just showed you on the last slide, they actually both boil down to insensitivity to parameters. People are under responding to probabilities in the former case, and they're under responding to time delays in the latter case. And this insensitivity, this is kind of the key thing I was showing in the paper, it remains when you take domain-specific drivers of behavior like risk and time away from the problem and just reduce it to pure information processing. So, a natural hypothesis is that complex information processing, one of the things that it might do in a lot of decision-making contexts, and I think this is something with potentially a lot of policy relevance, is it causes people to be less sensitive than they should be to things that matter. They're less responsive to things like taxes and time delays and risk. And this kind of insensitivity is a thing that might accompany complexity. So Ben Anke, Thomas Graeber, and Jeffrey Yang and I have a brand new paper called Behavioral Attenuation that runs 30 separate experiments covering lots and lots of types of decision-making domains. And we basically find significant evidence of behavioral attenuation there, complexity-driven under response to parameters. And the ambition of this kind of movement in behavioral economics is to see if we can find a small number of domain general cognitive mechanisms that can parsimoniously organize and extend the explanatory reach of behavioral economics. And so this is a kind of hopeful point of partnership between economics and cognitive science and neuroscience. Okay, that's it. Any questions?
Thank you so much. I I have some questions, but I am happy to have other people pose their questions first. I know we have um, some time um,
Sure. Yeah.
past the hour, but so so let me and if anybody has a question, just please raise your hand or just make a noise. So I have fundamental questions. I know nothing about this, of course, but how important is the money? I mean, in relationship to decision making, uh, because really my one of my main interests um, it's really trying to advance the science of risk prediction with Alzheimer's disease. So it's not money, is, do people want to know how much they are willing to know? So I see this as also of having certain weight, certain gain, but some people really see this as a loss. If I
Yeah.
know if I'm gonna get Alzheimer's, my life will be ruined. While other people think if I'm if I'm going to know my risk, I can do things, maybe, and others are very certain that they will have a positive outlook. We really do not know, really
Yeah.
at this
Sure.
point, particularly among Hispanics, because most of the risk determination based on biomarkers are done on non-Hispanic whites. So it's
So
very
it makes the diagnostics more difficult, huh?
so the risk prediction, because
I
we
guess I
can
see.
predict Alzheimer's based on the biomarkers 20 years before there is a symptom.
Right. I see. I see. Yeah.
So the risk of knowing, is it gonna be good for me or not? So we as a Alzheimer's Center, believe that we need to understand how to plan a natural experiment in a way. We have this, and so is this model, like, you think, for money thinking? I don't know if we think differently, or it's just the mental modeling of making decisions, what it's involved here in this.
Yeah. Yeah. I think that these things aren't entirely about money. So that, people have done very related experiments, and we have some experiments too that don't involve money explicitly. Um, but there are so some of them have to do with information, for instance, and this is what you're describing. There's a very neat literature in behavioral economics that's related to another literature in psychology on people's taste for the timing of information. So people have and you can show this in really simple experiments that involve nothing nearly as important as a kind of scary diagnosis, that people vary in apparent preferences for the timing at which a piece of uncertainty is resolved. And so there's a bunch of kind of work at the intersection of economics and psychology trying to understand exactly what that is and why it happens. And there are models of preferences for timing of information, where some people would, so for instance, some people want to learn bad news as soon as humanly possible. These are the people who will go into a clinician and want to get every test under the sun as soon as they possibly can, because they just can't handle waiting for that uncertainty. It's clear that there are also people of the opposite type who will do anything to delay having to face up to bad news. So it's an interesting question how it's related to some of the things I talked about today. I don't know how direct it is, but there is a kind of growing active literature trying to understand exactly these types of questions in economics.
I think that there is a niche there. And I'm happy that our faculty from our business school, like Marcy, and from psychology are here, like Laura and Akin Cheng. And I think that now with the interest on, potentially the head of the NIH being he's in this space of
And Alzheimer's. Yep.
no, in economics,
Oh yeah, right.
health economics. That's his thing. So I think I envision that there is a niche. There are already few applications to explore questions that applying things from the economic field to, you know, Alzheimer's, which is the disease that has the single disease that have more funding in NIH so far. And I don't think that's going to change, really, of all the things, given the age of our legislators. And
Right. Right.
I don't think that's going to change. So one thing has to do with the prediction of, um, of how, and I like the idea of the timing of the disclosure and estimating the impact of a disclosure so early, I mean, so in advance to actually having symptoms. Because we have no treatment. We can modify our lifestyle. So we
Right.
can, if there is a very high risk, we can postpone, which is good. But, some people will just not have that taste for, healthy lifestyle, even
Right.
after no, I'm not going to stop smoking. I'm not going to eat my vegetables. I'm not going to do yoga or something. So
Yeah. Well, I mean, it's as complicated as personality psychology in the sense that, we're not totally sure why there are some people who are, you know, the minute they get a rash on their skin are immediately, online trying to figure out exactly what it is and self-diagnose. They want to get an answer right away as soon as they possibly can. And there are other people who would do anything to not talk about their health and never see a doctor. And I'm not sure. I don't know about whether there's a literature on this in psychology, but if not, it's an amazing opportunity because it seems very important.
mhm. Dr. Seligman, thank you for being with us.
Oh, thanks. First of all, I want to say I really enjoy your talk. But
Thank you.
I had a really quick basic question, but have you looked at numeracy and whether people who, you would suspect this would be less complex tasks for those individuals, just the effects start to dissipate, or is it moderated by things like numeracy?
Numeracy, yeah. So not in this study, but there are some closely related studies that are kind of that end with the same kinds of conclusions about what people might be doing in these settings that have linked this stuff to numeracy. So there is a numeracy noisy, so if you think of this as noisy coding of information that gets distorted in a Bayesian way by the brain, there is a connection of how noisy of that noise and numeracy.
Okay.
I think Michael Woodford at Columbia has some work on this, but I didn't do it in this study. I immediately regretted not doing it in this study because it's kind of an obvious thing to have done, but I didn't.
Well, thank you.
Thank you.
So is there complexity, how stress adds to the complexity?
Yeah, that's a big question. I mean, so this is like a really hot issue in development economics, the economics of the developing world, where they're extremely interested in how stressors affect the information processing resources people have available to them, which if you face you can think of complex problems as problems that demand intensive cognitive resources. And you can think of a lot of types of disprivilege as generating lack of supply of information processing. So there's some really neat research on sleep, for instance, on like how people's decision-making quality changes when they, when they're lacking sleep because of stress, for instance. So I haven't done anything specific on this study involving that, but there's also literature on, my sense is that the literature overall is still not totally sure. It doesn't, there are studies going one direction or the other, but there's definitely some evidence that things like lack of nutrition, background stress, lack of sleep, kind of very typical things that happen to people who are poor, have big influences on cognitive, and basically the cognitive resources you have available to deal with complex problems.
So what you're saying has to do that it's not only financial literacy, really, what decide, the kind of investments that we make. And for example, in populations like in the Rio Grande Valley, where there is a lot of unbanked or underbanked populations, and we have a pawn shop in every corner, and other cash checking and check mechanisms. So when we think about all the fraud that happens, so it is almost like a gamble.
Yeah.
They change one thing for another, and it seems to be the normal way of operating because like everybody does that. So it's not only literacy. What the implications of your study is that it's not only knowing informed of the risk.
Yeah, and that's not that surprising when you think about it. I mean, how many things do you know better than that you don't do because it's hard, right? I mean, most people, I think, or at least many people, know that they should be exercising but don't do it because it's hard. Making complex decisions is the same. You can know enough to, in principle, do the right thing, do the optimal thing, do the thing that's most in line with your own goals. And because it's stressful, difficult, it involves exerting a lot of mental energy. It involves a lot of ambiguity. So for instance, just imagine the problem of filing your taxes. If you've done it a couple of times, you pretty much know how to do it, but a large percentage of people procrastinate it because it's painful in the same way that doing something physically stressful is painful. And it's also scary because you have no idea whether you're going to discover something during doing your taxes that's going to cause the thing to turn into a multi-week thing that involves a bunch of accountants. I think that things like this show up over and over again in social life, and I think that it's regressive. I think that the more experience you have doing really complex things involving forms, which a lot of us, by nature of our jobs, can do in our sleep because we're just used to it. If I grew up in Detroit. A lot of the people I grew up with are people for whom filling out forms is a lot scarier than it is for me, because I've been doing it seemingly every day of my life for the last 40 years. And you really wonder whether we create decision environments, even our government, even when they're have the best of intentions, create decision environments that are just extremely costly for people, lead them to make bad decisions.
And I'm wondering also, because we have a clinical cohort where, we have neuropsychologists, we have, phenotype people very well. And I'm wondering what having functional imaging of the brain could add to these type of processes, because we know that decision making involve specific areas of the brain, and people, let's say, with hypertension or diabetes are going to have some problems in those areas. But we also have the Alzheimer's who have that area kind of okay, but the memory is bad. So
Right. Yeah, and
they,
that's one of the key resources that, because it affects working memory as well, doesn't it?
yeah,
Not just episodic and long-term memory, but
yeah.
working memory. And working memory is one of the key resources that you need to deal with complex tasks.
So people with
Cognitive control, that's
yes,
another one. Yeah.
people with diabetes and hypertension in particular. And we have markers of impact of these conditions in the brain. So that might be something. So I think that Dr. Oprea, it has been a fantastic afternoon. Thank you so much. And I think hopefully we can invite you to come and come to our business school and to our neuroscience and psychology
Sure,
department.
I'd
Yeah.
love that. I'd love to meet you guys in person. It's I'm honored to be here. Thank you so much for having me.
Thank you very much. And I think that this is a field that really is very promising and quite important, really, quite important. Thank you so much.
Thank you.
Thank you, Ryan. I
Everyone
will
have a good day.
contact you later. Yes.
Okay, great.
Yes.
Neida,
Right, bye-bye.
bye. Thank you.
Okay, Neira. Okay, thanks for setting here these are our next announcements. We have the memory and heart connections, La Familia, going to be the topic, starting this Thursday at the BIST Central Building. And it is the BIST, the Brownsville Independent School District building. It's going to start at 8 o'clock. It's going to be interesting. We have a lot of international speakers already with us and cultural performances. It's going to be a full day activity. And also we are going to have on March 14 the RECMAR annual meeting. The RECMAR scholars and alumni interested in attending. It's going to be sorry, the March 14th, the registration deadline is going to be on April 22 to 24. And we have our next presentation of this seminar series is going to be presented by Dr. Jorge Igor Fuir. He's going to talk about navigating the,
January? It's January? Because today is January.
oh, this is not a date. Today is January 28th, so it's maybe in 2 weeks. No, Nera?
Yeah, I'm sorry about that. That was my mistake. Yeah, me too.
So it
No
should,
problem. In 2 weeks.
okay, in 2 weeks,
Mhm.
should be Jorge Igor Fuir talking about
Yes.
digital health landscape. So
Mhm.
about mental health and dementia through patient journal analysis. So it's going to be working and presenting on data analysis from large data sets from clinical settings.
Awesome.
Thank you, everybody.
Thank you so much. And I hope to see you on our event in the BIST. The team has been working quite hard, and it's going to be really very nice experience. And thank you so much. Thank you, Neida, as always, for putting together the event and Dr. Alier. So thank you so much. Thank you for all attendees.
Thank you. Stay safe, everybody.